Well, greetings everybody, and a fine good day to you. Welcome to Takeo Tuesday for this beautiful March 12th. John Barba from Takeo Comfort Solutions with you, and I'm flying solo today. My compatriots Dave and Rick are out actually doing work today, so it's a red letter day for Takeo. So I get the con today, and let me make sure I have the right screen for you. How about that? Hey, you're not seeing the right screen. Let's do it this way. How about that? Okay. I'll stop sharing that screen and I'll start sharing this screen. There we go. Nope, wrong one. Okay, let's try that again, my friends. Boom, 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 boom. Okay. Well, here's how we're going to do this. I'm going to have to move everything over here. All right. Here is my screen, and we're going to do this the old-fashioned way. Hope everybody's doing well. It's been a fine day. Oh, wait, I think I know how to do this. There we go. Slideshow. Yeah. All right, good. We're going to do it this way. Welcome, everybody. And again, thank you for being with us on this Tuesday for a discussion of domestic hot water recirculation. Okay, we're going to be discussing all different types of domestic hot water recirculation and the importance of designing and the importance of controlling your domestic hot water. That's kind of the important thing here, is to make sure that when it's not just slapping a circulator in there, plugging it in and letting it go. That'll accomplish the goal of domestic hot water recirculation. That'll get that part done. That's not difficult. The key here is making sure you don't turn this, A, that you control it properly, and B, that you don't turn the plumbing system into a sprinkler system. That's kind of the thing that we're really worried about, is turning the plumbing system into a sprinkler system when you really don't want to. That's where sizing comes in, and that's where control comes in. So we're going to start off talking about different types of domestic hot water recirculation, kind of a little bit of a recap of what we did last week. Some your typical customer, the typical problems that they'd like to solve, and then we're going to get into the specifics of how to make sure that that works for you and for them. So what I would like to do is, first things first, I want to make sure everybody can see the screen okay. It's a little bit not quite what optimal, but I think I have two different monitors, and I can't really figure it out on the fly, so we're going to go with what we have. Do me a favor. Before we get started, go down to your chat and question section and just type in a hi, hello, how are you? And let me know how everything's going. Let me know where you're from and where your name and where you're checking in from, and that you can see the screen okay, because I want to make sure that that's going to work, everybody. So we get Thomas from Maine, Charles and Thomas and Tom, and another Tom. There's David from Kansas. Welcome, Canada. Matthew, how you doing? Joey from New York. Roger from Oregon. Wendy from Maine. Boy, oh boy, we got a whole crew here. This is excellent. Great. Please do ask your questions as we go through this presentation as well. That's going to be the important part. I want to make sure that we kind of cover everything and you get the answers that you want. There's no question out of bounds. We don't hold questions till the end. I'll answer them as they come along, and we'll do the best we can in that respect. So let's get started with just some different types of domestic hot water recirculation. All right, there's and this is from a plumbing standpoint. First one is the normal one, the trunk and branch. That's the most common plumbing system that we have. Big water main goes down, and that's the trunk, and you just take branches off that to go to your fixture units. The most common way to achieve domestic hot water recirculation in that type of a system is to simply tee off of the hot water line at that farthest fixture and run a smaller diameter line, 1/2-inch PEX or copper or whatever, all the way back to the water heater. That's where your circulator is going to be, and that will do the job. That's the return line, and that will do the job of helping to keep the hot water line primed. Valerie asked a question right off the get-go, and I'm glad you asked that. When specifically do you need a recirc system? Anytime the code will say a lot about this. Code will say if the run to the farthest fixture is more than 50 feet or 100 feet. That's going to depend on the local plumbing code. They will say you must have a recirc line and a recirc pump in that application. How often that's enforced is a different discussion, but those are the general guidelines. In specifically, anytime you feel you have a customer that has to wait what they feel is an extended time for the hot water to get to that farthest fixture, then a recirc system becomes something that is preferable. It becomes a convenience item. It becomes a way to keep from wasting water. I mean, there's nothing more annoying than sitting there, stark naked in your bathroom with your hand in the shower, waiting for the hot water to show up, and it's a minute, minute and a half, or whatever. In some cases, it's not. In some cases, if it's an older home where it's a really short run from the water heater to that fixture, hey, it may only be 20, 30 seconds. But the bigger the home, the longer the wait. So I don't know if that answers your question, Valerie, but code will dictate specifically when one is required. After that, it's when one is desired. When will it be a convenience item, a comfort item, an economy item for the homeowner? So I hope that helps out. All right, let's continue. So there's your trunk and branch piping system, and then we have another option when you don't have a recirc line. This is more of a retrofit application, where you have a trunk and branch with a crossover valve under the vanity, let's say, of that farthest fixture, of that farthest bathroom. And this crossover valve, or sometimes it's a crossover circulator, which we'll show you in a second, crossover valve, what that does is essentially uses the cold water line as the return line going back to the water heater for your domestic hot water recirc system. So it's a simple crossover valve. Ours has a thermal sensor disc, a fast-acting snap-shut thermal sensor disc that will close that valve once the hot water arrives to minimize the amount of hot water that you might have in your cold water line. People look at that and go, oh my God, I'm going to have hot water throughout that line. That's crazy. Well, no, because the hot water doesn't graduate. When we have a hot water recirc line, when that pump is running, you got a big old slug of cold or tepid water in that line. And then when you turn the pump on, then the hot water is almost going to come immediately after that. So when it does reach that valve and snaps the thing closed, we're going to have a minimal amount, because it's a fast acting valve. There are slow acting valves. This one's a fast acting valve. Because it's a fast acting valve, we're going to have a minimal amount of warm or hot water in that cold water line. It's not going to fill the entire system. So that's a very common installation for retrofits, for existing homes that do not have a recirc line, and in homes in which installing a recirc line is impractical. You'd have to commit major surgery to the house. This works and works very well. And that's our hot link system. A crossover circulator can also be installed. We have a circulator that can be mounted under the sink. This is commonly used with tankless type water heaters, where you don't necessarily want the circulator running on a timer. You want it to run on demand. A push button enable, bam, it turns that circulator on, primes that hot water line, and shuts off when the hot water arrives there. Now, getting power underneath the vanity, of course, that is always a challenge, which is a limitation here, but it is also an alternative. So that's your trunk and branch with a crossover circulator, and that's the Takeo Genie, fits that bill. And then finally, there's for new construction, a way of thinking about plumbing, which is a full-sized hot water loop, where you have a full-size loop going from the water heater all the way around the house and back to the water heater for the circulator. So it's a full line, a full loop all the way from the water heater all the way back to the fixtures and back, with multi-port T's, as you see here, with those branches off of those T's running to each individual hot water fixture. This might be the most efficient way to install the plumbing system. And the shorter you keep those branches to the T's, the less tepid water will have to be replaced once you turn the faucet on. So that's another interesting way of doing a plumbing system, but this again is new construction from the ground up. And then a circulator at the recirc line, and that works very well. So those are your options when it comes to piping up a recirc system. Now I want to just talk at you a little bit, and again, do me a favor, folks. Let me know very quickly, how's the pace? I apologize for the hinkiness of the appearance, but I want to make sure it's looking okay, it's sounding okay, and the pace is okay. Also, I do want to point out that those diagrams that you saw, plus some of the other things you're going to see in a little bit, are in a handout. If you go to the handout section, you can download those diagrams, plus some charts we're going to look at a little bit later on about pipe sizing and velocities that are kind of important. So just know you can download those anytime you wish during the presentation. When it comes to your customers, when it comes to people who want domestic hot water recirculation, there are three types of customers. Let's go from right to left here. We're going to read this backwards. There's one section of subset of customers that they don't give a darn. They don't care about this. Code is requiring them to put it in, so they want just the cheapest thing possible. They don't want fancy, they don't want controls. Just put the cheapest thing in possible. I don't really care how well it works, whether it works, or what it does. I have to satisfy code. I have to check this thing off, and then we're fine. The second group also it can be categorized under they don't give a damn, or darn, excuse me. They don't give a darn. They don't care what it costs. They don't care how it works. All they want is instant hot water at the fixture 24/7. Whenever I turn a faucet on, I want hot water there. I don't want any excuses. All right. I don't want any excuses. That's a chunk of the consumer right there. So the first group that doesn't give a darn, they don't really care what it does or whether it works. I have to check a box on my checklist. The second group of doesn't give a darn, they just don't care what it costs to run. They don't care how much the electricity costs to run the circulator. They don't care about the wear and tear at the water heater that's going to cause that thing to run more and cost more to operate. They don't care about any of that. All I want is when I turn that faucet on 24/7, any time of the day or night, I'm not waiting for hot water, and that's on you. Don't give me any excuses. They're on the fringe. They're on the opposite sides of the bell curve. The big fat sweet spot of the bell curve is the don't like waiting or wasting people. There are folks that I don't want to wait for domestic hot water. It's a convenience item. I want to turn that thing on, and I don't want to have to wait 2.5, 3 minutes for the hot water to get there. I want it there in 10, 15 seconds or automatically. They don't want to wait. There's another section of that group that they don't want to waste. They don't like the idea of turning that faucet on and letting the water run for two or 3 minutes, going down the drain, waiting for the hot water to show up. That's wasteful. They know it costs money at the water heater. They know it costs money in water and sewer. And water is water. Water is precious. Okay, they don't want to see any of that. So that's kind of part of that group. They don't like wasting, or they don't like waiting, and for them it's a convenience or an ecology setup. So that's kind of where we're looking at here. Now Matthew says there's a fourth type who used DHWR as a freeze protection. The pump will activate based on outdoor temperature, planning using the crossover method to keep all the lines hot-ish. That's another excellent application, depending upon where you at, Matthew, because that may be more if you're in Alaska or someplace where freezing is an issue. That's a very viable alternative. Absolutely, absolutely. All righty, Barrie, Ontario, sure, up in the Great White North. Although Ontario, I learned the hard way. When I used to live in Minneapolis, I used to say when I was going to Toronto, I'm going to the Great White North, until somebody pointed out to me, said, hey, Rand McNally, Toronto's actually quite a bit south of Minneapolis. So that's kind of how that worked. All right, well, let's continue our journey here. To solve the problem, we have four options here. We have dumb pumps. We have slightly less dumb pumps. Then we have slightly less dumb pumps with an aquastat. And then we have a dumb pump with a smart control. So yeah, we're going down the dumb and dumber route here, but each one of these has an application, but each one except maybe the last one, and even maybe the last one, depending upon the application, will come with a warning sign that we're going to get into in a moment. But let's go through each one of these so you can see what they do and how to apply them. So first off, let's just look at dumb pumps. It's a dumb pump. It's a standard 00 series take-go pump with a line cord. You connect it, you plug it in, and you get the hell out of the way. All right. That pump will run 24/7, 365. All right. At whatever wattage the pump happens to be running at. So it's going to be using a lot of electricity. It can be done with an ECM circulator too. It'll use less electricity, but it's still running 24/7. All right. This is the solution for both of those don't give a darn customers. The person who says, I just gotta fill in the checkbox, I gotta satisfy code, I don't care if it does anything. This is their solution, okay? The other one who says, I don't care what it costs, I don't want to wait for hot water 24/7, 365. This solves the solution, this solves the problem as well. It's cheap and it's easy, but there's a lot of danger involved, as we're going to see. This may be from a standpoint of your concerns of your plumbing system, this might be the worst solution. Douglas says, not legal under recent energy codes, right? Depends on where you are. Absolutely, depends on where you're. I tell you what, we see this all the time. We see so many of these installed just like this, regardless of energy codes. Okay, regardless. This is going to use a lot of electricity and it's going to put a lot of wear and tear on the water heater, but no one's going to have to wait. And it's the cheapest thing to put in. But it's a it makes your plumbing system a sprinkler system waiting to happen. All right. We take a look at slightly less dumb pumps, Same idea, except we have a timer. All right, whether it's a digital timer or an analog timer, basically you tell it when you want it to run. I want it to run between 6 and 9 a.m. and between 6 and 9 p.m. or whatever it is, whenever it is you're going to be using domestic hot water. Two big questions with timers that I've never had anybody successfully answer is the first is, who sets it up? Who sets the schedule? Who actually programs this thing? All right. And if you've ever read the instructions for any of these things, it's like, what? I mean, I've been in the business most of my life, and they still kind of flummox me a little bit. So who sets it up is the biggest question. And then the second biggest question is, who resets it in case of a power outage, or what we just had this past weekend when we went into daylight savings time? Does anybody ever go back and reprogram these things? And I'd be interested in what you guys recommend to your customers. We've heard folks say, I just give the homeowner the instructions. It's their house. They figure out how to set it up. Or I ask the customer some questions and I set it up as best I can. And then we see what happens, right? I don't know what the right answer is. I don't know what the wrong answer is. It's just it's a question mark. Yeah, homeowner to a YouTube instructional video. That's the way a lot of stuff is done these days. But the biggest challenge we've seen is when they get set up, sometimes are they, whoa, there goes a picture. Are they set up properly? Are they set up to the customer's satisfaction? I've seen them over time. One of two things can happen here. It's either abandoned completely or it's set up to run 24/7. That's it. That's just kind of the way it is. So it's a solution. It is a solution. It's not without its questions, however. Then we have a slightly less dumb pump, meaning a pump with a timer, but then we additionally throw an aquastat on it. Because even with a timer, say I want that pump to run between 6 and 9 a.m., all right, it's going to be running a good chunk of that time for no apparent reason. All right, once you have a hot water line primed and ready to go, there's no reason for that pump to keep running, especially if you have like consecutive showers. We've already got the thing primed. So run it between 6 and 9 a.m. That's 3 hours of operation, 3 hours of electricity, 3 hours of water, water flowing through the water heater that we might not need. So to further make that a little bit more efficient, we can add an aquastat to the equation. So yes, it'll run between 6 and 9, but that aquastat is kind of like a low limit, high limit kind of thing, where it says, okay, I'm going to turn this thing's going to be on, the hot water line is cold. It will run and run and run until the hot water arrives at the point where the aquastat is installed. Then it'll tell the pump to shut off. So if it's at, let's say it's 105 degrees, at 95 degrees, the aquastat says, oh, the water's cooling down. Let's turn that pump on again. And the pump will run until we get to 105 degrees again. Oh, a nice solution to work in conjunction with the timer. The challenge is very rarely is this aquastat put in the best location. Pop quiz for you all. and type in your answer. Where do you think the best location is for the aquastat? At what point in the plumbing system will the aquastat do the most good? And here's a hint, it's also the least convenient place to put it. But let me see where you have it. Yeah, last fixture, Douglas has it right. Last fixture, Matthew's got it right. On the opposite side of the system, says Liz. Yep. Closest to the actual pump, Neil, is the most convenient place to put it. It's the easiest place to put it. It's where 99.7% of them are actually placed. But for effectiveness, the best place to put it is at that farthest fixture, because that's what we care about. Don't really care what the water temperature is in the return line. We just want to get that hot water to that farthest fixture. When the hot water's there, we can shut the pump off. All right. That's the best way to do it. Yeah, the return line at the water heater is easiest. Absolutely. That's why that's the spot where it goes most often, but it is the least efficient. You really want to maximize this, put it at the least convenient spot. I guess that's just the way it goes. So now we get to the dumb pump with a smart control. This is a dumb pump. This goes back to that first option we had, just a double O circulator with a line cord. All right. Whether it's ECM or standard efficiency, doesn't make any difference. Okay, doesn't make any difference. It's just a standard pump, but we use the Taco Smart Plug. We use the Taco Smart Plug, which is a kind of an award-winning control that is really simple to install. As you can see, it is a plug. You plug that into the wall, and then you plug the pump into the smart plug. There is a sensor that must be strapped onto the hot water line as it leaves the mechanical room. You have to include that sensor. And then what this control does is it learns your hot water usage patterns. It learns your hot water usage patterns over the course of a week, and then it replicates. It replicates. It only runs the pump when it knows you're going to be using hot water, and it's constantly relearning and reprogramming and relearning and reprogramming. So it's a constant fixture, a constant feature of that. It's always adjusting and relearning. Not quite artificial intelligence, but you get the idea. Here's what it does. Here's how it works. Let's take a closer look. What it does is it learns your domestic hot water patterns. When it runs, it's 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off. And if you install one of these, please note, it's a little weird, but its first operating format is the 10 minutes off. So when this thing is plugged in and you plug in the pump, it's not going to run for 10 minutes. It's not going to run for 5 minutes and then turn off for 10. It's going to be off for 10 and then go to 5. It's bass backwards, but we have people plug this thing and says, this thing doesn't work. Now you got to wait 10 minutes, then it'll start its process. So it's going to be 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off. We don't have to program. There's no dip switches or anything like that. The way this thing works is, say you install this, and then let's say you install it on a Sunday night, just as an example. What the thing's going to do for the first week of operation is it's going to pulse. It's going to do that 5 on, 10 off, 5 on, 10 off, 24/7 for that first week of operation. While it's doing that, that sensor, which is really important, is going to be recording what it considers hot water events, and events like a shower. So it's looking for a temperature rise, a sustained use, and then a drop off. So say that thing's pulsing 5 on, 10 off, 5 on, 10 off. So when you get ready to shower, you're gonna be pretty close to having a full line there of hot water. You take a shower. So this thing says, hey, at 6 a.m. Monday, somebody took a shower because I got an event. All right, I'm going to keep that in my mind. 6 a.m. somebody took a shower. It's going to do that every day of the week. It's going to have one pattern for each day of the week. The following Monday, it stops the 24/7 pulsing. But what it's going to do is that at 5 a.m., it's going to start that 5 on, 10 off cycle. And it's going to do it for a 2-hour period. So from 5 a.m. to 7 a.m., it's going to pulse that pump, 5 on, 10 off, 5 on, 10 off. So it really only runs 20 minutes an hour, right? 15, 5, 10, yeah, 20 minutes an hour, 5 on, 10 off, to keep that hot water line primed for that 2-hour period. Then it shuts off, all right? Then say someone does the dishes or something at 7 o'clock in the evening. Well, it says, okay, 7 o'clock in the evening, we had a hot water event. 6 o'clock, I'm going to pulse until 8 o'clock. The reason we have that 2-hour period is for a couple of reasons. Hey, you get up a little earlier, say you get up a little later, we're good. But also for what happened just this past weekend, we sprung ahead an hour, right? We're still good. It'll still be there at 7 o'clock when the time changes, or 6 o'clock when the time changes, and then it'll just keep relearning. So really powerful, really intelligent little control. Can you use the smart plug with any existing pump? Absolutely, doesn't matter. All it needs is a line cord, doesn't matter who manufactured the pump. If it has a timer on it already, just disable the timer, plug this thing in and let it take over. So absolutely, good question, Wesley. For those homes that do not have a regular schedule, because now a lot of people are working at home, there's no regular schedule for bathing or showering or anything really. It does have, and this also works for light commercial too, by the way, it does have what we call an optional pulse mode. So if you see at the bottom of the picture there, on the far right, there's a button called Mode Select. Okay, Mode Select. You can go from smart mode to pulse mode, and then it's just going to pulse 5 on, 10 off, 24/7. All right, around the clock. And a lot of folks, prefer that, depending upon their lifestyle. Where's the event data stored? In the unit itself. In the unit itself. And after a power outage, it just kind of picks up where it goes off, where it left off. Number one. Number two, if it's been off for a really long time, it's just going to, when it comes back up, it'll go back into the pulse mode, into the learning mode, readjust itself at time changes, and it has a vacation mode. So say you go on vacation, and if it senses no event for 72 hours, then it's going to say, hey, somebody ain't home. So somebody's not home. I'm just going to shut off. I'm just going to shut off. I'm going to exercise the pump once a week. And when you come back home and you start using hot water again, bam, it goes back into the learning mode, that 5 on, 10 off, and it starts the learning mode again. Okay, so that's kind of cool. So no, there's no cloud connection needed at all. It's a self-contained unit. All right. Question asks, what happens if we need hot water during the 10-minute off period? Well, here that's a good question, Ahmad. When it runs for 5 minutes, the idea is to get that hot water line primed. Okay, to keep that hot water, get hot water into that hot water line and keep that line primed. When it shuts off, you've got hot water in that line, for that time being. And then you use something in that 10-minute time frame. The idea is that hot water hasn't dropped off in temperature to be stone cold in that 10 minutes. Pipe insulation helps this performance immeasurably. Okay, but it doesn't. One of the things about domestic hot water recirculation, it's important to note, and we're going to make this point in a little bit too. It's domestic hot water recirculation isn't about pumping hot water to the fixture. If you took the recirc line out, you'd still get hot water to the fixture. This isn't supplying hot water. This is just keeping your line primed. So you'll always have hot water available. We just want to keep the line primed. That's all domestic hot water recirculation does. The pump doesn't supply water to the fixture. It's not a flow thing or anything like that. All it's doing is keeping that hot water line primed so that when you need hot water, you don't have to wait all that long. Okay. Let me know, Ahmad, if that answers your question. That's a good one. Is that right? So some installation options. Again, it's pretty simple. Whether your pump is on the supply or the return line, it doesn't make any difference. Whether you have a mixing valve or not, again, doesn't matter. The most important thing is that sensor is strapped onto the supply pipe as it leaves the mechanical room. All right, that's the most important thing. To make sure it senses that, even if you're in the pulse mode, you still have to have the sensor. Okay. Is that right? Very good, very good. All righty. Again, here's just an idea of what it does, that pulse mode operation. Again, if for that first week, it's 5 on, 10 off, 5 on, 10 off for days 1 through 7. And then after that, it's recording your hot water events. So again, here's your temperature rise right here. You can see that your temperature rise, your sustained use, and then the drop off. And then it's ambient, sustained, your temperature rise, sustained use, and then a drop off. These are the events that it measures. Once it measures those events and it understands the time, okay, then it can say, all right, 7 a.m. someone took a shower. I'm going to start pulsing at 6 and I'm going to stop pulsing at 8. Okay. Really, really cool piece of equipment. It won the 2017 Product of the Year award at the AHR Expo back in 2017. Of all the products that were, by these huge companies, this product was Product of the Year. This cute little smart plug, because it had the ability to affect and impact so many people, which made it pretty cool. All right, any more questions on smart plug? Just shoot them out there, guys. And again, let me know. Let's still status check. How are we doing? Is everybody happy? We're halfway through. Are we again, pace good? Any questions? Now just throw them on in there. Yeah, potable water pipe installations required for plumbing codes. Yeah, again, required, installed is obviously a different story, but absolutely yes. You insulate the pipes, everything performs better just by leaps and bounds. All right, from Neil, would you provide me the best recirculating pump for a tankless water heater in which there's no dedicated return line? If I recall, you mentioned the Genie yeah, what we've seen is with a tankless water heater, you don't want a timer. You don't want to run anything on a timer because you're going to be pumping water through that thing when there's no demand for hot water, no need for hot water. You're going to short cycle that sucker into an early grave. Really, really bad idea. Best thing there would be something like the Genie, where it is a push button operation. So before you're ready to jump in the shower, you hit that button, the circulator comes on, it runs 15, 20 seconds. Its goal is to evacuate that hot water line of cold or tepid water as quickly as possible, get the hot water to that fixture, and then shut off. And then the hot water use is imminent right after that. So the Genie does that and does that very well. It can be purchased with an under sink kit. It's called the Genie USK model, and you have all the parts you need to install it under the sink, including a wired push button, etc. Again, you still need power there to make it work, but that would be really the best way to do it, Neil. How much does the plug cost? We don't get into pricing here. That's going to be between you and your local wholesaler, but that's kind of the best way to do it. Wi-Fi to control from a phone or computer. Yeah, there's always future developments in that. What we do with the smart plug, the thing about smart plug is make it as simple as possible. Like just as simple as possible. If it knows when you're using it, then it knows when you're using it. The only time you might want to consider, I think, Wi-Fi is, hey, I'm coming home, I'm going to start using hot water again. I'd like that thing ready when I get there. That'll certainly do it. But if you've been gone for a week or so, and then you go on and open up a hot water faucet, it goes right into the learning mode again. So it's going to be 5 on 10 off. So there are workarounds on that one. Okay. Very good, very good. Let's see, is there a rule of thumb when a recirc system makes sense versus a star distribution system? A star distribution, Matthew, can you tell me what you mean by that? Are you talking about a home run type of system, or if you could just tell me what a star system is, I'd be happy to help you out there. The part number for that valve, part number I don't know, it's the Takeo Genie. This Takeo Genie with the USK suffix will get you to where you need to be. All right. Can you use multiple push buttons with the Genie? Absolutely. Multiple push buttons, either wired or wireless, as well as motion sensors. You can use motion sensors as well. Again, does anyone need to install multiple Genie USK kits in a home with multiple bathrooms? No, you actually just put it in the farthest fixture away, the farthest bathroom away. And again, just think about how it works. That farthest fixture, you're going to prime the entire hot water line. Start via manifold versus individual runs. Okay, it's a manifold, so like a home run type of system. You can still recirc with a manifold with a home run system. In terms of longest run, again, that's really going to depend on how long it takes for that hot water to get there. 30 feet 10 feet a half-inch pipe is going to have a cup of water, so that's pretty quick, right? So 30 feet, if 30, 40, 50 feet of home run, probably not going to waste a lot of water, and you're probably going to get there pretty quickly. What a lot of folks will do is they'll recirc from the water heater to the manifold. to make sure the hot water is at the manifold. Okay, that's probably the best way to do that, in my opinion. You don't need to recircuit the fixtures if they're close. The best would be to recircuit them to the manifold and keep that thing primed. Alrighty, very good, very good. Let us continue. Let us continue. And then here's another option that for that under sink installation where you do not have a recirc line. Yes, you could put the Genie under there, and with a tankless, that's the good idea. With a tank type water heater, now we're looking at the Hot Link Plus E, the Hot Link Plus E, which is a kit. It has the smart plug, it has the 006 E3 circulator, and our Hot Link crossover valve with the thermal sensor disc inside that snaps shut. And then you can see the installation there. Again, it prevents an appreciable amount or even a noticeable amount of hot water from getting into the cold water line. All right, question here is, what's the best way to tie in a recirc when you have a whole house thermostatic mixing valve? Really good question. There's actually I'll go back real quick here. I mean, this is one advantage of doing it this way. Boom, boom, boom. This full-size loop picture should probably give you an idea, and that picture is going to be in your handout. So it could be just typically like that on the return side, and there you can see your valve. You can put the pump on the supply as well. Either one, either way will work. Supply pumping away from the valve, or on the return pumping into the tank, doesn't really matter. So either way would work. You just don't want it to put it on. You just don't want to put it on the hot line between the water heater and the hot port of the mix valve. Then it doesn't do much. It's got to be on the outlet side, on the mix side of the tempering valve. Very good. Let me know if that answered your question, Adam. Okay. Now I want to get into sizing. The other part of this that's really, really important is sizing. Sizing the circulator is becoming more and more important because of the way we've done domestic hot water recirculation for so long. We've just chosen a circulator, plugged it in, and let it run. And what we have seen out there in the real world is we've learned what kills pipe, whether it's copper pipe, PEX pipe, CPVC, doesn't matter. What kills pipe? Any guesses out there? Let's just run that. But what kills pipe? What kills pipe? Erosion. Erosion, yes. And what causes erosion? What causes erosion? Velocity, right? And what causes velocity? Oversized pumps, big old pumps, right? We have just put in whatever circulator that we think is least expensive or commonly used or readily available, put it in, plug it in, and let it go. What kills pipe specifically is hot, chlorinated water running at high velocities continuously. Okay, 4 things: hot, chlorinated water, high velocities running continuously. Okay, now hot water, we can't change the temperature because the hot water's got to be the hot water. Heavily chlorinated, we can't do anything about that. That's, whoever gives us the water determines that. All right, but high velocities running continuously, those 2 things we can control. Those are the 2 things we can control, and that's what we're going to talk about next. So let's think about this. Does sizing domestic hot water recirculating pumps matter? Absolutely, absolutely. These pictures come from the Copper Development Association and corrosionpedia.com. This is what erosion looks like. All right, you see it changes in direction in fittings because that's where you get really turbulent, right? Somebody said velocity plus turbulence. Absolutely. That's where you're going to see this stuff first. And this is all erosion due to high velocity with hot chlorinated water. All right, so that's kind of what it looks like. And we have a sprinkler system. Happens to PEX too. Here's one from heatinghelp.com and surfacesciencewestern.com. This is what happens as well. You break down the integrity of the pipe simply by oversizing your recirc pump. All right. So why is this happening? Again, it's turbulent flow. It is high velocity, high concentrations of chlorine and high water temperatures. So that's the recipe. That is the recipe. So the pipe is trying to tell us something. we get holes in pipe for a lot of reasons, but these are self-inflicted wounds, right? These are self-inflicted wounds. And when you replace why is this happening to me with what is this trying to teach me, everything shifts. Everything shifts. So let's take a look. All right. As we said, elevated water temperatures, 140 degrees is kind of the magic number here. Velocities of over 2 or 3 feet per second. That's not a lot of velocity. That's going to become important in a second. Chlorines, chloramines, etc. And again, that killer of continuous circulation, that dumb pump, even that slightly less dumb pump with a timer, not our friend, not our friend here. So let's take a look at how we've got the control portion now. You look at the smart plug as a way of stopping, keeping continuous circulation from happening. The smart plug does a great job of that. So we've covered the control aspect. Now we got to cover the sizing aspect. All right. To understand sizing, and this goes back to a question we had earlier here, folks. Again, what is a domestic hot water recirculation pump supposed to do? Is it supposed to deliver hot water to the fixture? No, not at all. It's not supposed to deliver hot water to the fixture. If you took that pump out, you'd still get hot water at the fixture. We're not trying to pump hot water to the fixture. This isn't a pressure booster or a water deliverer. That's not its job. Its job is to keep the hot water line primed. That's it. And the cool thing is, the pump doesn't have to be very big. To make that work, the pump doesn't have to be very big. Actually, small is beautiful in this case. All right. Some things to understand here about maximum velocities. This comes from the Copper Handbook from the Copper Development Association. And just the highlighted sections, I'll read them to you. It's the first one is, water velocity limitations just simply in the distribution piping, not the recirc line piping, but just the distribution piping at 140 degrees, where water temperature routinely exceeds 140 degrees, lower flow velocities such as 2 to 3 feet per second should not be exceeded. Ordinarily, if it's below that, you could get up to 5 feet per second in your hot water line. Next, locally aggressive conditions can combine with these two considerations to cause erosion corrosion if system velocities are too high. So that's aggressive water. That's your chlorines and other crapola in the water. Now the next column. Due to constant circulation and elevated water temperatures, particular attention should be paid to water velocity in circulating hot water systems. Both supply and return piping should be sized so that the maximum velocity does not exceed the above recommendations. Care should be taken to ensure that the circulating pump is not oversized and that the return piping is not undersized. Both are common occurrences in installed piping systems. So what's this telling us? This is saying, watch your velocities and watch your pipe sizing, because that's what causes problems. Okay, that's what causes problems. So let's take a look at what we have for limitations. This is a chart for domestic hot water recirculation maximum velocities. This chart is in your handout. All right. If you take a look, you'll see we have the middle column. All right, that's your warm water. That's your domestic hot water at 5 feet per second. These are the flow rates, the gallons per minute flow rates that they recommend. So 1/2 inch pipe, 4 gallons a minute. 3/4 inch pipe, 8 gallons a minute. 1 inch pipe, 13.7 gallons a minute. That keeps you within your velocity guidelines for hot water for distribution. This is to get the water from the water heater to the fixtures. That first column is the recirc portion, 2 feet per second or 3 feet per second. Me being generally a conservative person, I lean towards the safe number, the 2 feet per second number. So if my recirc line is 1/2 inch, doesn't matter. Nothing else matters other than that 1.6 gallons per minute. 1.6 gallons per minute. That's the number I'm looking at. My recirc pump cannot pump more than 1.6 gallons per minute through that 1/2 inch line. That I design from there. I work from there. If my line is 3/4 inch copper, I can go up to 3.2 gallons a minute. All right. But I just want to make sure we understand what those numbers mean. That's not the flow rate to the fixture. Okay, that's the 4 gallons a minute. This is just when the pump is on and we're recirculating hot water, the flow rate through that recirc line has to be no more than 1.6 gallons per minute. Okay, so that's That's our type M copper. Type L, being a smaller ID, we're down to 1.4 gallons per minute. So it's going to depend. Do you have type M or type L copper in your plumbing system? Okay. So again, recirc, not flow. This is just the recirc line, not the flow to the fixture. It's the flow from the fixture. So when I'm sizing my recirc pump, my line in the sand here is 1.6 gallons per minute with type M, 1.4 gallons per minute with type L. Okay. Does that make sense? Let me know if that makes sense to y'all. Okay. And I know we have some questions here. I'm going to get to them in a second. With PEX, this comes from ASPE, the ASPE Plumbing Engineering Handbook. All right. For your cold water piping, your maximum velocities for PEX about 10 feet per second. For your domestic hot water piping, your distribution piping, the water going from the water heater to the fixtures, 8 feet per second. But now we look at that last column, your domestic hot water return piping, 2 feet per second, 2 feet per second through the pipe. All right, at a maximum operating temperature of $140. That's the limitation they're putting, 2 feet per second. So what does that mean in terms of gallons per minute? Let's take a look at this chart. If my recirc line is 1/2 inch PEX, 1.1 GPM is my limit. 3/4 inch, I can go up to 2.2. So that's the flow rate. When I'm sizing my circulator, when I'm selecting the circulator, setting it up on how I want it to run, that's the limitation, 1.1 or 2.2. Okay, those are the important things. Those are the important numbers. Now, what does this all mean? Keep calm and do the math. And I'm going to show you how to do the math in just a second. So here's just a quick diagram of what we're talking about here. So I've got a water heater. Here's the mixing valve. And then I just want to make sure that we understand we don't care about the flow through this first part up to this farthest fixture, the solid line. So I got 20 feet of 1 inch, another 30 feet of 1 inch, then I've got 40 feet of 3/4, 20 feet of 3/4, and then I've got about 10 feet of 1/2 inch right here to this last vanity. I don't care about the flow rate there when sizing my circulator. I care about the dedicated return line, the dotted line here. I care about the flow rate through that 130 feet. If it's PEX, 1/2 inch PEX, 1.1 GPM. If it's 1/2 inch type L copper, 1.4 GPM, type M, 1.6 GPM. Those are the numbers I care about. And the cool thing is you don't have to guess. We have a very, very cool tool for you that I'm going to spend the last few minutes showing you. A couple questions that came in. Can one reduce the chlorine level by using a whole host water filtration system? You can. I'm not sure how to quantify that, and I wouldn't size my circulator based on that, and I wouldn't choose my control strategy based on reducing the chlorine level, because you never know what's going to happen with the next guy. Always just keep the 1.1, the 1.4, and the 1.6 in mind, Neil, and you'll never go wrong. From Matthew, many cities are requiring hotels to install hot water recirculation systems to save water. Absolutely. Demand will vary every day to day. Thoughts? Yeah, you still have to have a system, properly sized and properly controlled. You know, demand's going to vary. Absolutely. I've stayed in hotels, and morning time, bam, everybody's taking a shower, bam, it's right there, it's ready to go. Take a shower in the middle of the afternoon, you wait a little bit longer. It's just the way it is. Depending upon the size of the circulator, again, a smart plug can handle light commercial pumps with ease. There's an amp limitation on it. I'd have to check the specifics on it, but that would be an approach. Absolutely. At what velocity does air leach out of the water? I've always thought slow movement air gets in systems and causes corrosion. Yeah, Valerie, it can. 2 feet, less than 2 feet per second, you're going to see in a closed loop hydronic system, velocities less than 2 feet per second, air starts to, dissolved oxygen starts to turn back into a bubble, and that creates noise. That can cause corrosion too, but more to the issue is noise. That's why we have that's why an air separator is a big open space in the piping, right? Velocity slows down and it comes out there. In a closed loop hydronic system where there's nothing really corrosive, we're not all that concerned about it. And how does low velocity impact minimum flow rate at tankless water heaters? Well, tankless is a different animal, Tom. That's a great question. Tankless is a different animal because you need at least half a gallon a minute going through that thing to make it fire. And you don't want to run it on a timer. That's the other thing. So velocity becomes less of an issue and pump sizing becomes less of an issue with a tankless, specifically because with an on-demand type of system like the Genie, you press the button, it comes on, it's high velocity, it's high flow, but it's going to run 15, 20 seconds till we get that water to the farthest fixture, and then it shuts off. Okay. That's the goal. That's the best way to run something with a tankless. Timers and tankless, bad mistake. I think it's a bad idea. And most of the tankless water heaters now are coming with their own domestic hot water recirc package. So again, always follow the manufacturer's instructions there. That's always the best way to go. All righty. Now what I want to do here is get this guy up for you. This is on the Taco Comfort website, tacocomfort.com. All right, if you go to tacocomfort.com and go to selection tools, let me see if I can find that. I'll go get tacocomfort.com right up here for you. Tacocomfort.com. Right here, you see selection tools. If you click on selection tools, you have a product, some commercial stuff, project builder. These are commercial system design systems. But then DHWR size right circulator sizing tool. This is for domestic hot water circulator sizing. So you click on that, and then you come up with this form. Okay, and you start filling out information. So the first thing you have to fill out, and what this is going to do is it's going to walk you through the whole thing. You give it some basic information, and it's going to tell you what circulator to use, and if it's an adjustable circulator like the 006E3, how to set it up properly. So first question it's going to ask, is there an existing or will there be a DHW recirculation line installed? Let's go yes. Okay. Water heater type. Click on select tank, tankless, or a boiler coil, like a tankless coil. We in the Northeast, we have tankless coils. I'm going to go with tank type water heater. Your piping layout. Is it a trunk and branch with recirculation, or is it a full-size loop like we showed you earlier? Let's go trunk and branch with recirculation. And if you see right here, it says view sample piping layout. You click on that, and you'll actually get a drawing of the sample layout. So you get an idea, a little bit of a visual here. Okay. Let's close that. Then we go to supply pipe material. Let's go with type M copper, and return type material. We'll stick with type M copper. Again, sometimes they're different because maybe you'll have different piping for the return line, but I'm going to stick with type M copper all the way around. Okay. Next, we go into our pipe size calculations for both the supply and the return. So you click on this green button and you start putting in your pipe sizing. So let's start with 1 inch, our trunk, our main, and let's say that's 50 feet, okay, of 1 inch pipe. Now we got to put in some 3/4 inch pipe. How much 3/4 inch pipe do we have? Let's say it's going to be 60 feet of 3/4 inch pipe. And then the last little bit will be 1/2 inch pipe. And let's say that is 15 feet. Okay, so I got 50, 60, 110, 125 feet total there. Now I go back to my return pipe. And let's say I'm going to go with 1/2 inch copper. And right there, it's telling you can see that right there. It's telling me my line has a maximum limitation of blank GPM. It doesn't give me anything because I haven't put in a run yet. And let's say, because we can snake that back, let's say it's 100 feet. Okay, it's 100 feet of pipe. Now it's telling me this line has a maximum flow rate limitation of 1.6 GPM. Okay. I scroll on down, and here's my flow rate, 1.6 GPM, and it's also calculating the head loss for me of 7.94 feet a head. Okay, and that's based on this information right here. Valves and fittings, 40% of all the different valves, ball valves, fittings, etc. 40% may be a little high, maybe a little low. You can adjust that if you've done an efficient system where there aren't a lot of fittings. You can certainly drop that down. I'm going to do that. I'm going to drop that down to 30% just to see what happens. All right, and that's going to change my head loss. Now it's down to 7.37. So okay. Now, is there a mixing valve present? Do I have a mixing valve here? Yes, I do. And now I got to put in the mixing valve CV or pressure, and you look that up in the mixing valve specifications. There's not there are a bunch of different types of mixing valve with different CVs. That's a pressure loss rating. You put in what that pressure loss rating would be for your specific one. In this case, it's 1.8. So I've done my calculations here. 1.6 GPM at 9.2 feet ahead. Okay, I got that. I got that. Now, circulator efficiency type, all or ECM. Let's just pick for fun. Let's pick ECM only. And connection type, flange sweat union. Let's see about union, see what we can come up with. All right, so I've got all of that. Now I just click on search, and what it's going to do is it's going to give me some choices. So I've got the 006 E3, as well as the as well as the Smart Plus E. Now the Smart Plus E is the 006 E3 packaged with the Smart Plug. All right, that's the difference. It's packaged with the Smart Plug. But dig this. I'm going to click on that, and look what it's doing for me. It's giving me the specifications. It's giving me a link to the catalog, a link to the instruction sheet, a link to the submittal. All right, it's giving me the part number. Some people asked about that. It's giving me the part number, and it's giving me a link to the product page. But here's what else it's giving me. Check that out. I click on the pump curve, okay, and it's telling me 1.6 GPM at a little over 9 feet ahead. What that's telling me is where I should set the dial, on my 006 E3, because it's adjustable. It's min, max, and there's different settings. Basically, I line it up with not with max, but with a little bit below that, with high, and I'll be at 1.6 gallons per minute. So it makes it very simple for you, and you can print this out, and that's part of your documentation. And that's important because, again, we want 1.6 GPM. If we set up the curve properly, that's what we will get. Are there any questions on this? Because this is kind of a very powerful little tool, and you can print it out, etc. But it's a very powerful tool that can do this process for you very simply. Okay, and get you into the circulator that you need, and help you program that circulator quickly with minimal fuss. So tell me what you think about that. Is there any issue having a return line larger, like 3/4? Well, good question. Scott said, I'm guessing you would want a larger return line if most fixtures are being used at the same time. That's why you want a larger supply line, Scott, not necessarily a larger return line. The return line is important for distance and for head loss. Because watch what happens. This is a good question, and I'm glad you asked it. I'm going to go up here, and I'm going to change that. I'm going to remove this. I'm going to put in 3/4 inch at 100 feet. What do you think's going to happen? What do you think's going to change? That's a pop quiz for you guys. What do you think's going to change now that I went to 3/4 inch? Look at that. The flow goes up and the head goes down. You got it, Douglas. Yeah. Yeah. Lower head loss. So now I did go up to 12. No, the head loss went up to 16.47. So the head loss didn't go down, but that's for one very good reason. My flow rate went up to 3.2. But here's something you got to understand. Yeah, Eric says the head should go down. The head should go down if the flow rate stays the same. What this is going to default to, and this is an important thing to remember here, it's going to default to the maximum flow rate for that pipe size. Just because it defaults to that maximum flow rate for the pipe size, that doesn't mean that's the flow rate I need. All right. Watch what happens if I go back to 1.6 here. I'm going to go back to 1.6 GPM, and watch what happens to the head. Now it goes down. Now it goes down to 4.6. Okay. That maximum flow rate is a maximum. It's not a target. It's not a target. If 1.6 gallons per minute is sufficient with a 1/2 inch line, 1.6 gallons per minute sure as shooting should be sufficient with a 3/4 inch line, right? And basically there's some ways I can figure that out. If I'm if I'm running off of the smart plug, right? If I'm running off of the smart plug, when it runs, it's 5 minutes on. So 5 minutes times 1.6 gallons per minute, that's a total. I'm over that 5-inch 5-inch line. Over that 5 minutes, I'm running 5 times 5. I'm running 8 gallons. That's 8 gallons. Now I'm going to show you something here. We show this button up here which says show details. It's going to tell you total amount of gallons in that run, that 1-inch pipe, the 3/4-inch pipe, and the 1/2-inch pipe. The total amount of gallons in that run going to that farthest fixture is 4.08 gallons per minute. All right, 4.08 gallons per minute. At 1.6 gallon, 4.08 gallons total. Excuse me. If I have running 1.6 gallons per minute for 5 minutes, I'm at that's 8 gallons total. I can clear that. I can clear all of the hot water out of that cold water line in less than 5 minutes. Okay, that's why we have the 5-minute run. All right, so I've got that line primed in less than 5 minutes. If I did run 3.2 gallons a minute, I could do it in a little over a minute, which is fine. But the head loss goes way up. Okay, the head goes way up, and then I got to buy a bigger circulator. So yeah, there we go. So in this case, yeah, 1.6 GPM, 4.6 feet ahead. That's going to be the same circulator. Okay, it's going to be the same 006 E3. But check out this. Now it's going to tell you to put the dial to low. How about that? Okay, so it's dynamic in that respect. Question is, how do you size for the Genie with no return? Really good question. And fortunately, we can do one. If you guys don't mind hanging out, I'll hang out as long as you want to. We go back up here and we're going to start over. All right. So no, there is no return line, no recirc line. I'm going to do a tank type just to show you how that works. Now let's do tankless. Let's do tankless because that's just the way that's going to work best. Crossover circulator, Genie. Crossover circulator, Genie. Now, notice supply pipe material. We only have one choice. We don't care about the return because there is no return. So it's just the supply. So what is that pipe? We'll go with PEX. We're going to go with PEX. All right, just for fun. Now, we only have to tell it what size supply pipe we have. So let's start with 1 inch, and let's say that's 35 feet. Okay. Then we'll go to 3/4, and let's say that's 30 feet. And then let's go to 1/2 inch, and let's say that's 15 feet. All right. So now I've got my totals, and you can see right here, we've already done our sizing. So here we're talking about 1.1 gallons per minute, 3.74 feet of head. Okay, and that includes valves and fittings of 60%. Now again, you can knock that down. It's kind of allowing for the tankless, but you can also add more pressure drop. You can add more pressure drop or more feet ahead here for your tankless if you wish to, and you can put in a mixing valve if necessary. But in this case, the Genie, we're talking about 1.1, 3.75. Hit select, and there's your Genie. Okay, and it's going to tell you which one to choose. The Genie's not adjustable flow like the 006 E3. There's just different circulators to choose from. In this case, it's the 006, the 008, or the 0011. They're all standard efficiency, but it really doesn't matter because they're only going to run 15-20 seconds at a pop anyway. They could be ECM, but what's the point, right? So this one here, the 006, works just fine. That would be the perfect circulator to use in that application. I hope that helps. All right. David, let me know if that answered your question. And for the rest of y'all, that's about it for the presentation. Make sure, again, go to the handout section and download the handout. That'll give you some information to work with. And let me know, was this worthwhile to you? Did you learn anything today? Was there anything useful that you can take away that'll help you change the way you do things? Okay, Ahmad, thank you very much for being here. Appreciate it. I like wonderful in all caps. Thank you, Richard. That's really cool. Maybe that makes me happy. Okay, cool, good stuff. Actually, excellent. Terrific, terrific. Glad you guys could be with us. I really do appreciate the gift of your time today. It's always fun to spend time together, and thank you for bearing with me. I just set up 2 monitors, and for some reason, I I didn't practice ahead of time, and I panicked. So that's all right, but it worked out okay. Um, so you will be getting an email tomorrow at about this time with a just a little thank you note, your certificate of attendance, as well as a link to view the recording of this if you wish to. So that you can watch that as many times as you want. And our next in this particular series is going to be on domestic hot water recirculation with heat pump water heaters. That's going to be really cool because the heat it's an evolving technology. The heat pump water heaters are fantastic pieces of equipment, but the idea of how to incorporate domestic hot water recirculation with something that doesn't want to run is going to be really, really interesting. Okay, that's going to make it. That's going to be a lot of fun and a lot of interesting discussions because we've talked with a lot of the heat pump water heater manufacturers, and they have some very specific requirements. They absolutely don't want long run times. They actually are looking towards manual enable with an automatic shut off temperature based because they don't want those things to run for very long because the more those things run, the more it impacts the compressor, which they don't want. So very interesting stuff. Very interesting stuff. Got a question from Tom. Still trying to figure out a retrofit DHWR for a tankless. Great info. Okay, excellent. I'm glad this helped. I'm glad this helped. And as always, I'll make sure it works in conjunction with the water heater you're using with the Rinnai and what their requirements are as well. But again, I think with any tankless, one thing we've learned from the manufacturers is they don't want to see anything on a timer. If there's no imminent demand for domestic hot water, they don't want water running through that thing because that'll burn out the heat exchanger in a hurry. And then there's no warranty, and then you got some splaining to do. So yeah, excellent. Ignacio, thank you very much. I appreciate it. Are there PDHs for this series? Yeah, you'll get a certificate, Victor, for 1 hour. And then you can submit that to your agency to see if they accept it. But we give you a certificate for 1 hour of attendance. So awesome, cool. Terrific, folks. Again, thank you so much for your time. It's a pleasure spending this hour with you, and I hope you all have a terrific week. And I don't know about you, but I'm real excited for springtime. Here in New Hampshire, we had a reasonably nice weekend. We had a windy day yesterday, but today's not bad. It's sunny. There's no snow on the ground. That means all the good things are coming back. So I'm excited. As the older I get, the less I like winter. I love that spring and summer. So thank you all. Have a wonderful, wonderful week, and we will talk to you soon. Take care, everybody.